Hi, grade 10. In this video, we are going to complete the chapter that we have started the last time. So, we were talking about forces. Now, we will learn about interaction. So, whenever a force is applied from an object on another, the other object would be exerting a force on the first at the same time. As you can see, I have a finger applying a force on the wall, and I have a force applied by the wall on the finger at the same time. So I always have two forces at the same time. Neither one of these forces can exist without the existence at the same moment of the other one. So I have always an action and I have a reaction. As you can see here, this man is pushing the wall and the wall is pushing back. I have an action and a reaction. Examples of forces. 1. The weight. You all know about the weight. So the point of application of the weight is the center of gravity of the object. The line of action is always vertical and the direction is downward, and the magnitude or strength is W equals m times g, and m is the mass of the object, g is the acceleration of gravity, which is 9.8 newtons. So these are the characteristics of the weight of any object. Normal force. This force is always perpendicular to the plane. So whenever you put something on a surface, on a table, on an inclined table or anything, this plane is going to do a reaction to this object, as you can see in both pictures. And this reaction is perpendicular to the plane, whether it's horizontal, the reaction N is vertical, and if it's not horizontal, it's exactly perpendicular to the plane, as you can see in the second picture. 3. Tension. Whenever I have a cable or a spring, I talk about tension. And this force goes along with the wave towards the fixed point. As you can see in the picture with the baby, I have a sort of a cable and the tension is going up. And to calculate the tension, I have to have two things. K, which is a characteristic of the spring or of the cable it will be given, and delta X, which is the difference in the length of the spring or the cable. So the elongation of the spring. Friction. So friction is a force that acts against or stops motion when two surfaces rub against each other. As you can see, someone is trying to push this block. I have friction from the opposite side. So friction is always opposite to the motion. Inventory of forces. W, it's the force exerted by Earth on a body. This is the weight. N is the force exerted by a plane on a body. It's the normal force. And T is the force exerted by a plane on a spring or a cable. This is the tension force. Now, components of a force. Let's say I have this force. It's not horizontal nor vertical, and I need to work with it. I need to solve some stuff with it. So to do that, I have to find the components of this force. When I say components, I mean something similar to abscissa and ordinate. So first of all, I have the orthonormal system, xy. Second of all, I project F on the axis of abscissas and on the axis of ordinates. This is how I'll get F of x, which is the component along the abscissa axis, and F of y, which is the component on the y axis. And I also have theta x, which is the angle formed between F and Fx. I have theta y, which is the angle between F and Fy. So F of x is equal to F times cosine theta x, and is also equal to F times sine theta y. So if you remember the trigonometry formula, I have a right triangle. The angle is in the end of f of x, if you can say. So cosine theta x is equal to f of x over f, which means that f of x equals to f times cosine theta x. And the same thing if you take the other triangle, the one with the theta y, the sine of theta y is equal to f. So sine of theta y is equal to f of x over f. So f of x equal f times sine theta y. Now for f of y equals f sine theta x, because sine theta x equals to f of y over f. And cosine theta y is equal to f of y over f. So this is why f of y is equal to f cosine theta y. Now to find the length of f, it's f of x squared plus f of y squared. This is Pythagorean theorem, because f is the hypotenuse. So to find the length of it, you have to square the other two sides and find their square root. Tangent theta x equals f of y over f of x. So we will need these formulas to solve the exercises later on. And this is all. Thank you very much, grade 10.